This is Chrisferb, and I'm going to review a uniform probability distribution example. So with a uniform probability distribution, it's also known as a rectangular or reticular distribution, meaning its probability is the same within the whole distribution. So whether it's, say, a range of the lowest to the largest, in our case it's going to be 0 to, say, 15 minutes. It's the same probability of occurrence, and that makes it a rectangle. Okay, so the amount of time in minutes that a person must wait for a taxi in Fresno, California is uniformly distributed between 0 to 15 minutes. So there's two parts to this question. What is the probability that a person waits less than 12.5 minutes? And then part B, what is the population mean and standard deviation, meaning population standard deviation? So the uniform probability distribution, like I said, it's like a rectangle. So what we're doing, it's also a continuous probability distribution. It's very similar in a way to the discrete probability distribution, except it's continuous and the probability is the same for all of the values. But with that, I'd say it's very similar in the way that it's kind of set up. Okay, so we'll start off here. Let's see. So the first part, when we're calculating what I would say is the height, is this. This is the formula that we're working with. So with our formula, B is the largest and A is the smallest. So B is the largest. So it's the largest value in the range, and then A is the smallest value in the range. So for our problem, we put 1 right there, and then the largest value is 15, and then minus 0. So we end up with 1 over 15. So this is our height of our distribution. Okay, this is our height. Now it's a continuous probability distribution, so just like any type of continuous probability distribution, we're finding actually the area under the curve. In this case, it's not a curve, but it's a rectangle. So we need the height and the width. Okay, so our problem talks about 0 to 12.5 minutes. Let's take a look at the first one here. So what we're going to do is now we're going to go and find the width. Now the width we go and we calculate by finding the upper, lower. For our area that we're concerned with, for our width, we are going to do this. 12.5 minus 0, because that's what we're concerned with, less than 12.5. And we end up with, of course, 12.5. And that's just part of it. So we have 12.5, but then, and that's our width right here. Now to find the actual probability, we have the width, we have the height. I'm going to draw this thing out real quick. This is what it looks like before we solve it here. This would be 15. This would be 0. This would be F. It'd be 1 over 15. So that's how, other than the rectangle looks a little bit unequal. So this is the distribution that we're working with. Now we're only trying to solve this. 12.5. So we're trying to find this part right here. So we know the height of this thing is 1 over 15. And the width we're looking for is 12.5. So what we have to do is we take 12.5, of course, in any type of math, to find the area of something, we multiply the width and the height, or the length and the width, depending upon how you look at it. So we have our width and then our height, 1.15. And our answer ends up being 0.8333. So you might look at this and you go, wow, that looks small, but we're dealing with probabilities. So in probability land, this would be, right, 83.33%. Okay. And remember, in probability land, this would be 0, and this would be 1, because this would be inclusive. Okay. All of the probability would be within this 0 to 15. It's a continuous probability distribution. So this is our answer for part A, which is 83.33. That's the probability, or probability that we are going to receive a taxi within 12.5 minutes in Fresno, California, theoretically. I'm assuming it'd be actually a lot longer, but I made this question up. Okay, for part B, we're just going to review some of the formulas for finding the population mean and the standard deviation. So the mean, or mu, is this. And this is actually just a weighted, or actually just an average. So it's very, very basic, our mean for this. So when we look at this, it would be 0 plus 15 over 2. And of course that equals 7.5. So that would be our mu. And I'm going to scoot this up. And then our standard deviation is so it is b minus a, and then squared over 12. For our problem, it ends up being, so we have 15 subtract 0 squared, and then 12, and we end up with 4.3 is our standard deviation. So just recapping, this is the probability right here, 0.8333, or 83.33% of waiting 0 to 12.5 minutes. And the mu, or the population mean for this distribution, is 7.5 minutes, and then the standard deviation is 4.3 minutes. Thank you for watching.